high-tech safety engineering.
Firefighters get to the location, this has got to work.
Cutting-edge die-cast construction and precision fabrication on a mammoth scale.
It's good to know that we can get that kind of quality into our parts.
All to build a blaze-busting vehicle that's a matter of life and death.
Lives depend on what we do and make sure we do it right.
To create a super fire truck, you need a super factory. Pierce Manufacturing. Battling a raging blaze, failure's not an option. For firefighters, only one thing stands between them and deadly chaos. Their fire truck. From mega frames to high-pressure hoses, high-tech front cabs to superior safety rigs, souped-up engines to ladders that reach the sky. A fire truck's more than a vehicle. It's a mobile rescue unit, ready for any crisis. For generations, Pierce Manufacturing set the gold standard, building custom cutting-edge fire trucks that battle blazes and save lives. Today, no company in the world crafts more firefighting apparatus than Pierce. 1,800 vehicles a year. And now, they've created the ultimate fire truck, the Pierce 30-meter heavy-duty ladder model. This firefighting powerhouse is a jack of all trades. It can reach 30 meters and shoot a water jet at a blaze-busting 7,500 liters a minute. Top it off with precision point handling, motion-sensitive safety innovations, and life-saving ladder equipment. And it's taking the fire truck to high-tech heights. Pierce manufactures this heavy-duty fire truck at their super factory in Appleton, Wisconsin. This mammoth facility boasts nearly 75,000 square meters of manufacturing might. It takes 45 days, more than 1,500 workers, and some serious muscle to build these rigs. With over 2,000 different custom packages, there's no such thing as a standard truck.
If you look at our industry, there's 33,000 fire departments. Now, every one of them fight fires differently. We've got to be flexible with our designs.
To build one-of-a-kind trucks, Pierce factory engineers faced a challenge, setting up a manufacturing process with custom capabilities. Their solution? Dividing assembly into multiple steps with production flexibility. Frame up, where the chassis foundation takes shape. Fabrication, where welders craft the truck's aluminum cab and body. Paint, where steel gets its shine. Assembly, where workers install thousands of components. And aerial assembly, where the massive ladder attaches to the finished truck. Here's how a Pierce 30-meter aerial fire truck design lays out. The open cab interior holds the driver, seating, and critical safety equipment, enough to outfit a team of 10 firefighters. A 3,000-liter center-mounted water tank connects to a high-power pump. A reinforced center support structure called the torque box holds the mechanics for the mammoth aerial up top. This 7,000-kilogram ladder, stabilized by a rotating platform and 4 hydraulic arms, gives the truck its 30-meter reach. And powering it all is a heavy-duty diesel engine, connected directly to the main mechanical systems. But to get a fire truck off the ground, it all starts here. Frame up, where the massive chassis foundation takes shape. When it's done, this 10 by 1 meter frame will shoulder the weight of the entire truck and its heavy payload, including onboard equipment, firefighters, and liters of water. All adding up to a staggering 32 tons.
If it's a big aerial unit, there's big ladder units and things like that. Big tankers will haul a lot of water. They have to be heavy duty.
The foundation frame starts with 2 steel rails. These two black beams must quickly become the rock-solid base of a state-of-the-art fire truck.
Here in Frame Up, we like to say the truck starts here.
Frame assembly comes down to two things: keeping it straight and level. Everything about a fire truck's foundation has to be square. Workers use an overhead hoist to slot the frame rails into a massive jig. With the help of air-powered stabilizers, the jig seats the rails 86 centimeters apart. With so much riding on these rails, the exact parallel angle is critical. Now, to keep the rails in a strong load-bearing square, the team installs cross members. Over a lifetime of operation, heavy cargo and twisting pressure put tremendous stress on the alignment.
They're very heavy-duty frame rails. They are probably 13 inches tall, where in your normal passenger truck, rails are maybe 4 inches tall.
But the frame is only as strong as its weakest link. The bolts that hold the rails together are as important as the rails themselves. To ensure workers tighten bolts to exact specifications, the crew uses a carefully calibrated instrument called a stall tool, a wrench with built-in control.
Some of our specialty tooling are stall tools that automatically stop when they reach the correct torque. Stall tools allow us to tighten and torque in one step without having to re-torque with a regular torque wrench later.
Workers fly the fully assembled frame to a waiting suspension assembly. The suspension system includes the base structure for the engine, transmission, wheels, and brakes. This groundbreaking independent front suspension system's called the TAC-4. When a fire truck's on its way to a raging blaze, saving time can save lives. Compared to most trucks' standard straight axle suspension, this heavy-duty system handles more like a sports car, allowing the truck to make tighter turns and faster stops.
This is the one thing that we have done in the past 20 years that I think is going to save more lives than any other safety feature that we have.
The TAC-4 independent front suspension has a military pedigree. Pierce's parent company, Oshkosh Truck, first designed and built the suspension for the U.S. Armed Forces. The troops put the suspension through over 100,000 actual test kilometers in extreme off-road conditions.
Thousands of military trucks are delivered daily with independent front suspension, and that's what we've captured and put into a fire truck.
To build each component of the TAC-4 suspension, the Pierce team starts with a precision-engineered laser cutter. Raw steel's the heart and soul of every fire truck. First, the system carefully chooses the proper bin, depending on what it's cutting. This tower holds 10 bins of steel in total. Each shelf has a maximum capacity of over a ton.
We run through about 60,000 square feet of material a week.
Suction cups grab the raw sheet metal and load it onto the laser cutting table. The laser cuts through plates with speed and power, up to 4,000 watts of energy. The laser burns out supports and connecting pieces that bring the suspension together, working through the raw steel with tolerances down to the micromillimeter.
We're not building Swiss watches here, but it's good to know that we can get that kind of quality into our parts.
The laser cutter also minimizes sheet metal waste using a computer program called optimization nesting software. The software processes up to 3 days of cutting orders at once. The result? Less scrap.
Whichever way they would fit into the sheets the best is the way the software is going to divide them up.
To free them from the nest, the arm lifts and drags the cut parts over a metal rake.
And it'll be all different parts, different part numbers, but basically, this is all for the TAC-4 independent front suspension.
As the fire truck suspension build continues, the TAC-4 assembly is divided into 4 critical parts: the wheel hubs and rotors, brakes, and a wishbone-shaped connector called the control arm that attaches the whole assembly to the truck. The Pierce fire truck's control arms are souped-up versions of what's found on many SUVs.
control arm subassemblies are similar to what your A-frames are in most of your cars and pickups nowadays.
The difference is, this control arm makes an SUVs look downright anemic. The TAC-4 control arm is built to carry massive loads, allowing fire trucks to haul more fighters and equipment to the scene. With the control arms in place, it's time for the hub and rotor assembly, key parts of the suspension's wheel and brake system. Hubs and rotors install as a unit. Rotors are vented discs inside the wheel frame used for braking. Hubs connect the whole wheel construction to the truck. To install hub and rotors together, first pressurized rams rivet 10 studs into the hub. These sturdy bolts will eventually support the fire truck's big wheels. As the build continues, it's time for the brakes. When firefighters speed to an emergency, running red lights, it takes powerful brakes to stop 32 tons of fire truck. To meet the challenge, Pierce supersized the 30-meter ladder truck's brake system. A hoist lowers a massive clamp or caliper onto the wheel's brake rotor. The caliper's the mechanism that actually squeezes the brake rotor, making the truck stop. These monster brakes can stop a truck going 95 kilometers an hour, 20 meters sooner than standard brakes can. That's 4 car lengths, a life-saving difference. Like the rest of the wheel assembly, this caliper's huge.
It's about 10 times bigger than what's on your car.
And the truck's special anti-lock brakes have another built-in safety precaution. It's called Electronic Stability Control, or ESC. On snow and ice, a fast-braking truck can spin out of control. But with ESC, the system senses dangerous road conditions and adjusts the braking pressure tire by tire. ESC re-stabilizes the truck's direction and speed, helping the driver regain control. Now it's time for the chassis to get some cutting-edge tires.
15-inch diameter for a regular vehicle, and this one's a 22.5.
These wheels have a built-in bonus, a special tire protection band located between the metal wheel frame and the rubber. In the event of a dangerous blowout, the band keeps the tire rubber attached to the wheel frame. On a racing fire truck, it's vital.
You don't want the tire coming off the wheel. That's catastrophic.
Now, after 3 days and 4 major build stations, the chassis suspension build's starting to come together. It may not look like a truck yet, but in a fire emergency, each critical detail translates directly to safety, speed, and stability on the road. The cab and all its components are the brains behind the fire truck's brawn. By the end of the build, this 4-meter long by 3-meter wide metal box houses the key elements of the fire truck. Here, the driver and team strap in for the white-knuckle ride. The cab's cockpit-style dashboard gives the driver precision control. Customized gauges, switches, and levers direct and monitor many of the truck's mechanical systems. From steering to radio communication, sirens to lights, and high-powered pumps to onboard water supply. But first, the cab needs a strong foundation. Pierce believes to build a cab right, you've got to break it down into sub-assembly steps, each run by high-trained specialists with quality control every step of the way. The cab build starts in the fabrication department. First, welders fabricate the back of the cab, welding the aluminum skin to the rectangular bars of the substructure. Pierce custom designs this metal matrix according to the different cab layouts, adjusting for overall dimensions, storage and seating configurations, windows, and door design.
You get different mount variations and tubes going different places, so you kind of have to pay attention that you know where everything needs to go.
Now, to weld a flawless joint, fabricators use a secret weapon, gravity. Tilting this welding table ensures everybody's working at the perfect angle.
It's a better way to weld it when it's flat to put these tubes in place.
The rear wall's the base for the rest of the cab. This assembly process is also critical. Done right, it anchors all of the cab components to come.
This is the rear wall. When this is ready to go on the cab, the substructure is built, and they'll have the sides on. So you'll have your sides here and over here.
The cab fabrication team now faces a challenge, attaching the wall frame to the outer surface without warping. Welding the outer skin directly onto the main structure creates a twisting tension called torsion. The torsion warps the outer finish. Even a slight twist can distort the truck's body, especially along the main side structures that give the fire truck its solid shape. After experimenting with fixes, builders came up with a radical but simple solution: double-sided industrial strength tape. They apply the tape to the foundation supports, then attach the supports to the skin.
Basically, all it does is stick the skin to the framework, because there is welding all on the interiors of the frame that sticks right on. And then once you clamp it, forget it.
The welder now goes to work on the skeleton. He joins the cab's frame substructure using traditional welding techniques. Surprisingly, one part of the cab assembles with nothing more than industrial strength glue: the truck's doors. It's an innovation that cuts hours off the total build time.
The unique thing about bonding doors together, there's no welds whatsoever. The door is totally bonded together.
The builder applies a liberal bead of epoxy to the door components. He puts the parts into a fixture and tightens the mounts by hand.
It's a two-part epoxy we use. It's very strong.
Workers have just 10 minutes till the adhesive sets. For an airtight seal, they've got to go beyond hand tightening. As a series of hydraulic clamps lock the part into place, the glue's drying fast. But it all comes together, a solid airtight seal. Once finished, it's tough like a weld, joined in a fraction of the time.
Our old doors versus our new doors, again, we saved a lot of hours doing it that way.
After over 30 hours of total build time at several different cab stations, the cab support structure all comes together at the final weld assembly. A rooftop arrives on an overhead crane, a front end, and structural supports. Fabricators on either side of the center aisle assemble cabs like three-dimensional jigsaw puzzles. Every move matters. Workers know this build and every finished fire truck has a lot riding on it.
They want to ensure that when that apparatus needs to go rescue someone or save someone, it's going to perform at its highest level.
But Pierce and the fire truck industry had far humbler beginnings. Bucket brigades, handheld ladders, and steam-powered pumps first became the modern fire truck in the early 19th century. When newly invented skyscrapers caught on fire, they needed high-tech trucks to put them out. Founded in 1913 by brothers Humphrey and Dudley Pierce, Pierce Manufacturing began by reconfiguring pre-made truck and bus bodies for construction and delivery. Then, in 1940, Pierce started outfitting them with firefighting equipment. Early fire truck orders were for small-town fire departments' custom trucks, built one at a time. But Pierce's first big order came in 1956. 41 firefighting trailers for the city of Minneapolis. And that was just the beginning of a firefighting revolution. Today, Pierce builds a wide range of firefighting apparatus. Their pumper trucks carry high-powered water pumps that turn fire hydrant flows into high-pressure jets. Their expandable rescue trucks become on-site command centers with computers and satellite hookups. And their aerial trucks carry firefighting teams, massive ladders, demolition, ventilation, and breathing equipment. And as the build on this custom aerial model, a Pierce heavy-duty 30-meter ladder truck heads into the next assembly stage. This empty frame's about to transform into a full-on fire truck.
We pay attention to detail. For our firemen, they take great pride in their product. We take great pride in putting the product together.
From raw steel to gleaming top coat, the painting process happens in 5 major steps: metal finishing, pre-treatment, primer, paint, and buffing. First, metal finishing smooths out any imperfections caused by earlier welding steps. If workers find any warp or distortion, they flatten it. They make sure each cab and chassis turns into a smooth, blank canvas.
The metal finishing will take out the defects, fix any weld marks.
But it's dirty work. So dirty, the metal finishing area is known as the mud room. Here, workers use a glue-like putty to even out the surface, filling in tiny crevices. A technician adds a special blue-colored chemical catalyst to the cream-colored epoxy. The blue catalyst starts a chemical reaction, hardening the putty. The finisher layers the paste onto the metal surface, spreading it out flat. For the final touch, technicians take a rotating sander to the dry epoxy.
Body filler gives the ultimate finish once you get the paint on it.
Now it's time for pre-treatment. This crucial process removes any dirt or outside contamination.
It's really the most critical process. The paint will not stick if that process is not done correctly.
The paint technician gives the naked shell a thorough wash. He uses a different chemical solution depending on what kind of material's in the booth: aluminum, galvanized steel, or stainless steel. This job's strictly hands-off.
We focus hard and try to get everybody not to touch them even with their skin because of the oils in your skin.
This truck's ready for a custom paint job. Working in teams of 2, technicians use compressed air-powered paint guns to spray on the high-gloss paint. There are no robots here. Pierce prides themselves on a one-of-a-kind truck with unlimited color schemes. This build step counts on the human eye and touch to get precise results.
We can match anything. All they have to do is bring us in a sample and we can color match whatever they want.
When it comes to choosing the color of a fire truck, Pierce's 100+ color samples keep any engine company covered. The sample room's designed to inspire. And modern choices move beyond old classic red.
Seminole County, Florida did a couple trucks that were this bright orange. The Forestry Service has used this kind of pea green. Hawaii likes to use this 104 yellow. We've done some for the FBI and they've had some different shades of blue with some silver.
But no matter what the color, the final product has to be able to stand up to the worst extremes of any firefighting situation. To ensure a durable finish, an 80-degree oven cures the paint for a full 2 hours. Next, the painted cab and chassis head here, where technicians buff and shine the surface. A trained finish painter scours the surface under bright lights, looking for any blemishes.
Some are small little specks of dust, some stuff after it painted settled on it when it was in the oven.
Even the tiniest imperfection gets a fast fix. Teams sand, buff, and shine away all glitches. They won't stop until it's truly a flawless finish. It's now time for the main assembly line. Here, the fire truck starts to come together with some of the most critical component installations. Teams assemble all the finished parts, from frame-up, fabrication, and paint. But the next build step gives this fire truck major muscle: the engine. Diesel engines are the driving force behind every fire truck, sending power to built-in hydraulic generators that run the aerial devices, lights, and other critical parts. Pierce equips all its trucks with basic diesel engines. But it's up to the fire department to decide what kind of engine power plant they want. And most important, how much raw horsepower.
We use several different engines in our fire apparatus. It can be either a Cummins, Caterpillar, or Detroit diesel engine.
A forklift wheels engines into a small staging area. This is a 515 horsepower Detroit Series 60 diesel engine. This engine's known for its turbocharged pickup, fuel efficiency, and the ability to handle extreme conditions, running smoothly at temperatures over 50 or as low as 40 degrees below zero. An overhead crane lowers the assembled engine into place in the frame. With so much wiring already installed, assemblers must execute the engine drop to the exact centimeter.
There's thousands of dollars worth of harnesses and components that are already installed in that frame. It's a very tight fit and you don't want to wreck anything.
This blaze-busting fire truck now gets a set of custom pipes. Teams install the muffler and exhaust system. With so many unique options and configurations, there's no such thing as a standard setup.
All exhaust systems that we do are all custom. We cut them to make them fit, to make them work on the trucks.
Before the cab's dropped on the frame, it's first wired and outfitted with lights, sirens, and trim. This overhead hoist adjusts to carry all of the various custom cab configurations.
We've got different models of cabs and different configurations of those models, roof heights, lengths, things like that.
As it swings into place, teams of two position the cab onto the completed chassis. But above all else, one thing sets this truck apart from the pack: safety equipment. The second leading cause of firefighter deaths is traffic accidents. For Pierce engineers, it all comes down to fighting back against the worst accident of all, a side roll. The momentum of a skidding side roll causes the wide load of a fire truck to overturn, crashing onto its side. 60% of all traffic deaths involve a side roll. Pierce fought back against side rolls and other accidents with a motion-activated high-tech safety defense system. Each of its automated seatbelts, retracting seats, and airbags respond to dangerous tilting or skidding in nanoseconds.
When a firefighter is going to the scene, the adrenaline is flowing, there's a lot of things going through the mind of what they're going to do when they get there. The last thing they need to be worried about is the occupant safety of that vehicle.
In the truck assembly process, safety starts with the seat system. A technician installs the unique PS6 model seat and seatbelt unit. Unsecured occupants can suffer neck-breaking impacts, but this smart system reacts in an emergency. First, the belt tightens around the occupant. Next, the seat drops to its lowest position, giving the firefighter maximum headroom. The PS6 seats in the rear of the cab also contain the firefighter's lifeline, his breathing equipment. Seated firefighters can easily strap on a stowed air tank while still in the truck. The motion-activated brackets lock the tank safely in place. But when a firefighter needs to go, they can easily slide the breathing rig out. A cab assembler installs the side curtain. Without these inflatable airbags, metal walls become deadly points of impact. In the event of a side roll, the inflatable tubular structure, or ITS, triggers in moments. The bag stays inflated for 10 seconds, cushioning the occupant throughout the entire accident. Lastly, the cab assemblers tighten the cab to the chassis and make all the electrical connections. Now, a hoist operator places the high-powered water pump directly behind the cab. The pump will get fully hooked up and outfitted later on, once the truck body and water tank are completely installed. Next, it's time for the rock-solid spine of the entire fire truck, the torque box. Fully equipped, this black box protects all the electrical wiring and hydraulics for the aerial ladder. And on the road, the torque box works like a lightning rod. bearing shock and ladder tension, taking the pressure load off the chassis and body. It's so strong, you can hang the entire truck from it.
Ours has a very large box that runs, it's about this size, and it runs the full length of the truck up to the water pump. In there, we not only store our ground ladders, but this is the strength that allows me to do what I'm doing now. Basically, my truck is just hanging from this torque box.
Metal workers make the torque box out of 2 pieces of 2.5 centimeter steel. Fabricators bend the metal to create 3 walls and use 1 sheet of metal to cap the box. This technique minimizes welds, making the structure extremely strong. The crew installs the 3-ton tube using an overhead crane. Though the ladder itself adds on later, the whole foundation of a ladder truck like the Pierce 30-meter heavy-duty model in the making relies on this big box.
Meat and potatoes of your truck, you can't run your ladder without your torque box.
And for fire departments across the country, a ladder truck like this one is often the most critical vehicle in their fleet. As they extend up out of the torque box, aerial ladders have to stand up to frame-busting stress. Lifting up 30 meters, carrying a 450-kilogram payload, including firefighters, excavation tools, and rescue and breathing equipment. In the chaos of a raging fire, state-of-the-art aerial ladder rigs like Pierce's are lifesavers. They're so important, fire departments conduct ladder tests to make sure their rig's always in perfect working order.
So what we're doing is we're just simulating that we've got a fire on the top floor. We're going to try and ventilate this thing, make it easier for the firefighters to get into.
In this test, San Diego, California's Fire Department Station 11 extends 4 ground stabilizing arms, called outriggers, and raise the ladder to the top of an 8-story high-rise. The goal is to set the ladder about 15 centimeters from the roof line, avoiding the jutting, potentially unsound roof edge.
In a situation like this, what it's going to be is we're going to use this ladder to get people down. Not necessarily from the roof, but from the patios or from their rooms, if possible.
When these firefighters need to heat things up even further, Station 11 ladder truck teams come here, an ex-naval training facility turned firefighter and fire truck test ground.
We simulate boat fires, tanker fires, car fires, structure fires, even some wildland stuff. It's an outstanding tool.
A closed-room fire test is underway. Ladder truck teams swiftly mount the 30-meter ladder, moving to the roof to ventilate from above. The lead man first sounds the structure to make sure it's safe.
Roof sound!
To avoid a fatal collapse, the Station 11 ladder team stays along the edges of the roof. Moving across the roof is called going cross-country, and it can be the fastest but most dangerous route to take.
I'm checking the roof to see where the hot spots are. This thermal imager will tell me where the hottest spot on the roof is, and that's exactly where we want to cut our hole. That's where we're going to get the most bang for our buck.
The ladder team opens the roof with a chainsaw to ventilate the burning room. Ventilating lets in cooler air, releases scorching heat, and helps clear toxic, visibility-impairing smoke. But once the holes are cut, the team needs to get off the unstable roof fast.
This is no place that you want to be. It's probably one of the most dangerous things that we do. So our SOPs are, as soon as we get that hole cut, we're off the roof.
The only way off the roof is with the aerial truck. Its reach and reliability are a matter of life and death.
If we can't depend on that rig, then that's our lifeline, so to speak. So it's very important that we have a rig that's very dependable.
And now at the Pierce factory, this aerial truck workhorse is ready to move on to the next build phase. The bells and whistles that give it firefighting finesse. It's time for this road warrior to get dressed. All the firefighting bells and whistles. It needs wiring, lights, and some classic exterior diamond plating. At Pierce, no model's complete without this glittering touch. Part durable reinforcement, part old school decorative design.
We see diamond plate every single day, all day, and it's really easy to work with.
Diamond plating's tough metal protection's made from formed aluminum. It stands up to years of abuse, but with a little elbow grease, diamond plate's brilliant shine also lives up to its name.
I think the diamond plate looks really neat shining down the road, whether it's daylight or dark, you know, it's just glimmering on those trucks.
Next, teams of two lower the rear body onto the frame.
You got a piece right there on the front.
With this intense noise and obstructed views, team communication's next to impossible. To stay connected, workers use headsets and radios.
Craig, all the wires look good?
We're looking good, Mike.
Going down. When we've got somebody that's reaching underneath a body and it's suspended from a crane, ultimate goal, safety, make sure everybody ends up going home at the end of the day.
Next, for added firepower, Pierce installs a water tank. In an emergency, fire trucks can pull water from their reserve tank before they hook their hoses up to a hydrant. These corrosion-free tanks are made from polypropylene, a super strong plastic that's also lightweight. Tanks can hold up to 10,000 liters. As it goes into the truck, perfect placement's critical.
You've just got a small area to drop it, and you want it even in, you know, from the sides and in the front and the back.
As the build continues, it's time to outfit one of the fire truck's most important parts, the water pump. The water pump's main plumbing base was installed during the cab build. Now, a worker outfits the base with pressure gauges and controls. The amount of pressure determines exactly how fast and hard the water leaves the hose. This powerful pump system creates enough pressure to spray water up and out, extinguishing a raging blaze.
It all comes down to pressure. You need pressure in order to get the water to the supply where the fire is.
The pump panel and all its gauges are mission control for a firefighter's water discharges. Here's how the water pumping system works. Firefighters attach a line to the pump's main intake. Inside, a moving part called an impeller spins to create pressure, as churning blades push the water in a circle and feed the pressurized water up the hose lines. From one hydrant, they can have up to 8 charged lines snaking out of the fire truck, fighting fires on multiple fronts at once. The system can handle up to 20,000 liters per minute. That's enough pressure to send water up a 30-meter aerial ladder and still have plenty of power to unleash it in a fury.
You could break windows, rip shingles off roofs, you can do anything with it pretty much. It's a real heavy-duty piece of equipment.
This equipment's designed stout and simple, so firefighters can operate it in heavy clothing and thick gloves. Levers and connections are oversized for easy operation in sub-zero temperatures and over long, grueling shifts. Technicians install more accessories to customer specifications. Lighted compartments, custom shelving, and generators are just a few of the options. Firefighters can trick out these trucks with any combination. In a firefight, these add-ons can make a big difference.
Now the cargo floor is getting ready to go on. We usually get generators, hose reels, cord reels, accessories like that, and that's where they go in.
A generator adds extra juice to an already powerful truck. The engine drives the generator as needed, producing electricity for the night scans, floodlights, and other electrical options.
When the firefighters get to the location, this has got to work. Okay, down, Steve.
As they work, generator installment teams pay close attention. In the field, lives can depend on this single piece of equipment.
Extremely important that everything's installed correctly.
At this custom build stage, assemblers also trim the trucks with a touch of personality. Custom painted grills fly the American flag, or in this case, the Texas flag. An assembler affixes the Pierce badge.
I care about what they're going to go through, so it's important to me to make sure that my job is done really, really well.
An assembly technician loads more accessories onto the truck. These special pike poles are designed to ventilate ceilings and tear open roofs to let out lethal heat and choking smoke.
Every fire station selects their own style and different type of pike pole and different quantities and mounts.
Pike poles are some of the tools Pierce specifically installs at their factory. But Pierce engineers have to make sure there's ample room for fire departments to load up their ladder trucks with everything they'll need for any emergency. Aerial models like the heavy-duty 30-meter fire truck are specifically designed as mobile cubbyholes with secure storage compartments for life-saving tools and equipment located throughout the truck.
And trucks are nicknamed the big red rolling toolbox because that's what they are. They're a bunch of tools, the ladder for aerial observation, also aerial firefighting capabilities, but they have all the tools.
And the same heavy-duty aerial fire trucks must cope with emergencies beyond burning blazes. This highly trained firefighting team tackles ocean rescues, car accidents, and medical crises.
It's a chainsaw. It's a rescue saw. We can use this for forcible entry. In the next compartment here, we have our rope. We have our ground ladders. We're always on the ready. Everything's here that we need for any type of call.
At the Pierce factory, our heavy-duty aerial truck has its critical inside components. It's ready for the mammoth part that gives it its name. At Pierce, fire truck graphics add character to custom rigs. No image request is too small or big. From long-standing traditions to rolling tributes to fallen firefighters, fire departments can leave their unique mark.
The graphics department at Pierce works like a candy store.
It's fun, and it's always something different.
It all starts with a design. Graphic designers use standard templates and their own creativity to build the complete graphics package. The designer then outputs the custom image on a thermal resin printer. This resin works like a life-size decal. Artists finish their detailed work on the decal here, then affix it to the truck later on. It allows them to finesse and refine without making potential mistakes on the truck itself. The Pierce graphics team uses a process called gold leafing, an expensive and challenging craft that takes finesse at every step. The artist first applies 23-karat gold leaf to adhesive-coated lettering, tapping off the excess gold. The pricey paper comes in 3.5 by 3.5 inch sheets. One small box can cost as much as $800. And here, nothing goes to waste.
We sent it in last time, 6 garbage bags full, and we got $11,000 for it, so it is worth cleaning up.
Next, the artist gives the gold added texture. The gold leaf bonding agent sets quickly, so the artist must swirl the metal fast as possible using a small cotton pouch. Too little pressure and the gold won't swirl. Too much pressure and it comes off. Finally, the experienced team outlines everything with a steady hand.
We hear a lot of times, we could never do that. How do you do that? Well, we could never run into a burning building and pull someone out. That's just not in our knack. They have a lot to be proud of, and they put a lot of that into their design and to their fire truck. So to be able to help them bring that to light is really something special and something we take pride in.
The design decal's ready at last. A graphics applicator affixes the handmade artwork. It's a melding of old tradition and modern technology.
It's traditional gold leaf. It's absolutely, positively the exact same product that the old gold leafers were doing by hand right on the truck 50 years ago. The only difference is we do it in a controlled environment and we do it on this clear adhesive-backed vinyl so we can apply it like a decal. We're doing a process to a higher standard than almost anybody else.
The graphics are looking good, but it isn't a finished fire truck yet. The next assembly process builds the ultimate part for the final add-on. the ladder. Workers already installed the ladder's torque box base, but to craft its towering aerial, the part that literally lifts firefighters into the sky, Pierce turns to Kewanee Fabrications, an industrial builder in neighboring Kewanee, Wisconsin. This factory burns, cuts, and presses massive parts for heavy equipment around the world.
The company began in 1941, and that tradition continues today.
Kewanee fabricates ladders both from lightweight aluminum and heavy-duty steel, according to customer request. But meeting Pierce's tough specifications is a huge challenge. Each 30-meter ladder is only allowed to deviate by 1 centimeter from perfectly straight. But any amount of welding naturally pulls and distorts metal. Without correction, the welds on either side of the ladder's rails will make it bow like a banana.
The most challenging part that we see was trying to keep the rails straight when we started our process. Because of the welding being done on one side of the rail section, it caused a lot of distortion.
To solve the problem, Kewanee engineers experimented with fabrication tests and techniques. The solution? Reverse bending. Fabricators first pre-bend the ladder rails over metal blocks. A 10-meter section bends up to 8 centimeters from center to tip. This way, under welding, the pressure just pulls the ladder the other way, making it straight. The next build step at Kewanee is the aerial turntable. This turntable is the ladder's base unit, a rotating pedestal. Inside, the ladder nests in 3 sections. In a fire, hydraulic cables extend the ladder sections upwards. And operators can rotate the turntable in any direction, placing the ladder with pinpoint precision. To craft the turntable, metal assemblers fabricate the platform from 4-centimeter thick pieces of steel. With such heft, a standard weld won't cut it. It takes multiple steps.
You can't really do that in one pass efficiently and have the strength that it should have, so you end up layering it. There's about 8 passes in there to get that 3/4-inch weld.
Lastly, teams paint and inspect the fabricated aerials and send them off to the main assembly. It's time to attach them to the fire truck itself. At the Pierce final assembly area, crews outfit the ladders with life-saving equipment. Workers mount extension and retraction cables, hydraulics, electrical wiring, portable breathing air, and waterways. Pierce's heavy-duty aerials like this one lead the industry with 700-kilogram load capacities. They can also stand up to 80-kilometer-an-hour winds while shooting water at a blaze-blasting 3,500 liters a minute. Two mammoth cranes lift the ladder into position. The team carefully connects the 7-ton aerial to a round anchoring hub called a pin. As operators line up the unit, they've got mere centimeters to work with.
It is like threading a 15,000-pound needle.
At last, after nearly a month and a half of robotics technology, tireless labor, dozens of workers, and assembly finesse, the Pierce 30-meter heavy-duty ladder truck's finished. It's ready for a station house to put it to the real test, battling a blaze.
There's a huge sense of pride in putting these trucks together for the firefighters, knowing that they're going out and saving lives and rescuing people every single day.
It's a super fire truck, a life-saving rescue rig on wheels. And creating this custom vehicle takes a fire truck super factory. Pierce Manufacturing.